Creating compound inequalities. A compound inequality is when two inequalities are combined into one statement by the words and or. A solution of a compound inequality joined by and is any number or numbers that make both inequalities true. A solution of a compound inequality joined by or is any number or numbers that make either inequality true. A solution set is a collection of numbers that solve an inequality or an equation. The intersection of two sets, A, B, is a collection of numbers that are in both solution sets and is represented by set A and set B, written as A with this symbol, an upside down U, B. So that's A intersect B. The union of two sets is a collection of numbers that are in either set or in both sets and is represented by set A or set B, written as A, U, B. So you can remember it because union, the symbol is a U for union. Here it looks like an N for intersection. But what if there are no numbers that solve a compound inequality? Then we have a null set. Assume there is a solution set A for one of the inequalities and a solution set B for the other inequality, but none of the numbers are common to both inequalities, so there is no intersection of the solution sets for the compound inequality. This is represented by two non-intersecting circles. The null set is written as empty curly braces or an O with a line through it. Given two inequalities, x is greater than -2 and x is less than 3, find and graph the solution set if both inequalities are true. So first, we graph each inequality on a number line. This one is x is greater than -2. This line here represents x is less than 3. Then draw a third graph that shows the solution set for both inequalities by finding the intersection or overlap of the two graphs. The two graphs overlap between -2 and 3 on the number line. Both graphs do not include the numbers -2 and 3, so an open circle is plotted for each of those numbers on the third graph. Now let's write a mathematical expression for the combined inequalities of x is greater than -2 and x is less than 3. The solution set, shown here, includes the points between -2 and 3, but does not include -2 or 3. Therefore, the mathematical expression is -2 is less than x is less than 3. Given two inequalities, x is less than or equal to -2, or x is greater than or equal to 3, find and graph the solution set where either inequality is true. First, graph each inequality on a number line, shown here. Then we draw the third graph. Since this is an OR function, the solution set includes all the numbers in both equations, so both rays are drawn on the third graph. Both graphs include the numbers -2 and 3, so a closed circle is used for those numbers on the third graph. Let's write a mathematical expression for the combined inequalities. The OR operation means that the solution set for both inequalities are true. This is the union of both sets. You would just write x is less than or equal to -2, or x is greater than or equal to 3. Write a combined inequality from this graph. You can see there's no intersection or overlap between the two rays, so this is not an AND combined inequality. The solution set for the combined inequality includes the solution sets for each one independently, with an OR operation. So this is x is less than or equal to -6, or x is greater than or equal to 0. Write a combined inequality from this graph. There is an intersection or overlap for this graph, so it is an AND combined inequality. The solution set for the combined inequality includes numbers between -5 and 2. However, -5 is not included in the solution set because it's an open circle. Therefore, the answer is -5 is less than x is less than or equal to 2. Write a combined inequality from this graph. Since there's an overlap on this graph, it is an AND compound inequality. The two inequalities represented here are x is greater than or equal to -4 and x is less than 2. So we can rewrite it like this. -4 is less than or equal to x is less than 2. Write a combined inequality from this graph. Since there's an overlap on this graph, it is an and compound inequality. The two inequalities represented here are x is greater than -3 and x is less than or equal to 4. They join together to form the compound inequality -3 is less than x is less than or equal to 4. Write a combined inequality from this graph. There's not an overlap or intersection on this graph, so this is an or compound inequality. The two inequalities represented here are x is less than or equal to -5 or x is greater than 1. Because this is an or compound, the two inequalities are not combined into one.